Hello everyone. In this lecture, we are going to study about an introduction to AC circuit. A circuit with alternating current used for domestic and industrial purpose are called as an AC circuit. In an alternating circuit, voltage and current periodically reverses its direction. Few home appliances that use AC are refrigerator, toaster, dishwasher, etc.
An output graph for an AC circuit and DC circuit is shown here. In a DC circuit, current flow only in one direction, while in an AC circuit, current periodically changes its direction, causing periodic reversal in voltage as well. Let us consider a coil placed in a magnetic field. There are two methods to generate AC voltage: by rotating the coil at constant speed placed in a magnetic field, or by rotating uniform magnetic field at constant speed within a stationary coil. So, when a coil is rotated at constant speed in a uniform magnetic field, we get a curve of or a sine wave as an output. Let us study about that. When coil is at point O and D dash, the output that we get is 0. When this coil is moved at point A dash having an angle theta, then we get an output at point A, that is a linear increase in the graph. When this coil moves to point B dash, we get an angle of 90 degree, that is at B we get a graph at this particular peak point, which is the maximum voltage. Now, when coil moves to point C dash, we get output at this point C. And as the coil comes to point D dash, we get output at point D. That is, a half cycle has completed and the coil has moved to point D. Now, when coil again continues moving to point E dash, we get an output at point E. And when coil moves to point F dash, we get the maximum peak at negative half, that is minus EM. Now again, when coil continues moving to point G dash, we get an output at point G, and when coil again comes back at point O, we get a point at the graph point, that is at 0 point. So here is a formation of one complete cycle, that is a combination of a positive half and a negative half. This complete set can be called as a cycle. The voltage and current equation we get as a result of generation of AC voltage are E is equal to Em sin omega t, which is equal to Em sin 2 pi f t. Omega is replaced by 2 pi f. And current can be obtained as I is equal to Im sin omega t, which is equal to Im sin 2 pi f t. The basic terminologies that we will be studying here are waveform, cycle, time period, frequency, peak value, peak to peak value, instantaneous value, phase, and phase difference. Let us study about waveform. Waveform are the shape of a curve obtained by plotting instantaneous value of alternating quantity, that may be voltage or current, along y-axis and time or angle along x-axis. The graph can be a triangular waveform or a square waveform or sinusoidal waveform. Second terminology is cycle. One complete set of positive and negative values of an alternating quantity is called as a cycle. One cycle is equivalent to 360-degree or 2 pi radian. The third terminology is time period. The time taken for measurement of a complete waveform of one cycle is called time period. The time taken for one waveform to complete one cycle can be called as a time period. While frequency is the number of cycles that a waveform completes in 1 second. The number of waveforms that can be completed in 1 second can be termed as frequency. The next term was peak value. The positive or negative maximum value attained by a waveform is called peak value. It is also known as amplitude. The maximum positive and maximum negative point in a waveform is called as peak value. The next term is peak to peak value. The peak to peak value of a sine waveform is the value from positive peak to the negative peak point, which can be termed as peak to peak value. Instantaneous value is the magnitude of waveform at any instant of time. At this particular instant of time, the magnitude of waveform will be at this point. At this particular time period, the magnitude of waveform will be here. Magnitude or instantaneous values are represented by small I or small v according to the alternating quantity for which the graph is plotted. The next terminology is phase. Phase of an alternating quantity is the fractional part of time period or cycle through which the quantity has advanced from the selected zero position of reference. The first sine wave shown here is having a phase starting from point 0, while the other is starting from a negative point of reference line. So these two have got a difference in their phases. Phase difference can be defined as if the two curves are not passing through their maximum value or zero value simultaneously, they are said to have a phase difference. The first graph has got a leading quantity with a maximum peak point, while the second graph has a lagging quantity. there is a difference in their peak points, as well as at their zero reference point there is a phase difference of angle theta.